Okay, so in this video I want to go back to example 2 and show you why there is only one solution for a triangle that is side-side angle. And then I want to take a look at an example of an ambiguous case and just make some observations about the two triangles that we would get when the ambiguous case results in two solutions. Okay, so let's go back to example 2. We have a side-side angle triangle which we know could result in no solution, one solution, or two solutions. So why does this triangle give us 1? Well, what I would like to do is just to rename our angles, not P, Q, and R, but A, B, and C, which means that side P is actually side A now, and side Q is side B. And let's compare side A and B. We know that A is 24.8 and B is 23.4. And if you go back to your diagrams under the ambiguous case, you can see that when A is greater than or equal to B, you would have only one solution, and that's the case here. If you take a look, A is bigger than B, so longer than B, so A is greater than B, and therefore there is only one solution for this triangle. Okay, so I'm going to ask you to take out a separate sheet of paper, and I'm just going to add some notes in under here. Okay, and what I'd like to do is compare or just make some observations about a triangle that is an ambiguous case where you come up with two solutions. So we're going to take a look at triangle ABC. Okay, and we know that I'm going to give you that angle A is 45 degrees, side A is 15, and side B is 20. Okay, the first thing that I want you to be able to do is to look at this information and decide on whether you have an ambiguous case or not. Okay, so let's find the height. We know that the height for this triangle will be B sine A. And so the height is equal to 20 times the sine of 45 degrees. And you get that the height is 14.14. Okay, so you can see that the height is shorter than A, and A is shorter than B. So what we have here is H is less than A, which is less than B. So 14.14 is less than 15, which is less than 20. And if you go to your chart up here, you can see that when H is less than A, which is less than B, you have two solutions. So we know that this triangle will have two solutions. Okay, now I'm not going to solve it for you right now. I've already done that. What I'm going to do is just show you what the two triangles are, and I just want you to make some observations about them. Okay, so here is the first triangle that you will get. Okay, where all the angles are acute. So you get A, B, C. You will find that we already know that side A is 15 and side B is 20, and that angle A is 45. That's what's given. When you solve this triangle, you will find that side C is 19.1, angle B is 70.5, and angle C is 64.5. Okay, the second triangle that you will get with this is the one where you have an acute angle. Okay, so here is A and our given angle of 45. side B, which was given as 20, and side A, which was given at 15. And then when I went through and solved, I found that side C is 25.5 degrees, and angle B is 109.5 degrees, and side C is 9.1. Okay, so the first observation I would like you to make is that in the first triangle, so let's call this triangle 1, and let's call this triangle 2. The first observation I'd like you to make is that angle B in triangle 1 and angle B in triangle 2 are supplementary. Okay, so angle B in triangle 1 is supplementary with angle B in triangle 2. Okay, in other words, they add up to 180 degrees, right? That's what supplementary is. So 70.5 degrees plus 109.5 degrees equals 180 degrees. So when you're working on triangles that are ambiguous and you know you're going to have two solutions, you're going to find that your angle B in one triangle, your first triangle, and your angle B in your second triangle will be supplementary. Okay? Now, second observation is that your supplementary angles have the same sine ratio. Okay, so sine of 70.5 degrees and sine of 109.5 degrees should be the same. So let's check that out on our calculator. Okay, so sine of 70.5 is 0.9426, and sine of 109.5 is, look at that, 0.9426. Okay, so that's another observation that you can make with these two triangles. Okay, the other one that I would like you to make, this is our third one, okay, is that the sine ratio of sine 70.5 and sine 109.5 are both positive. Okay, so the sine ratios of sine 70.5 and sine 109.5. In other words, they are both equal to positive 0.9426, right? Both of them positive 0.9426. So what does that tell us? That tells us that these angles are in the first and the second quadrant, okay? And also that 70.5 degrees is the reference angle for 109.5 degrees. Okay. So we also know that 70.5 degrees is the reference angle for 109.5 degrees. Okay, so I'm hoping that these observations will help you when we work on the next question. Okay, so let's end this video here, and then I'll go on to the last example for this section in the next video.